Let's continue on now. Exercise 2.15, completing the square. Now what we need to do when we're completing the square is, at the moment, we're just trying to figure out what the missing term is going to be. So this is not mathematically correct the way we're going to write it, but we are completing the square. It's basically just saying what's the missing number going to be. So for this particular question here, effectively I'm saying what number is going to go into that box so I could complete the square on x squared plus 8x. The way we complete the squared is check, is it a 1x squared? There must be a 1 in front of it. Yes, it is a 1x squared, so I don't have to take out any common factors. Then we need to find half of the number in front of x and square it. Half of the number in front of x, half of 8 is 4, and 4 squared is 16. So that's the number that I'm missing, and if I then wanted to factorize that, it would be, because 4 times 4 is 16 and 4 plus 4 is 8, I'd get it down to that stage there. So I'll talk to you more in detail later about where we're going to use this. You're not going to really use questions like this by themselves. They're going to be incorporated into things, and we'll go through that later. So realistically, with part B, I want to figure out what goes in the box. Now this one is a much messier one because of the fact that the number in front of the x is an odd number, not an even number. Now, first thing to check, is it a 1x squared? Yes, that's okay. In front of the x, what's half of minus 7? Now, half of minus 7 is minus 3.5. So that's what half of minus 7 is. But I need to remember to square that. And when I square that, I end up with 12.25 if I want to write it as a decimal, although I'll often write those as improper fractions. But that's the number that I'm missing. Now, what two numbers multiply together to give 12.25 and add to give minus 7? Because we completed the square, it's always going to be half of that number. It's going to be minus 3.5. So the answer, if I wanted to take that further, would be x minus 3.5 in brackets squared would be what I'd end up with if I was completing the square on 1 part B. Now let's try some harder ones. You rarely get questions like this. I certainly don't see them very often appear on HSCs. Don't know that I can recall any, but we're going to go through the process. We need to figure out what would go in the box. Well, the number in front of the x squared in this case is 5 over 2. And what I'm actually after is a half of 5 over 2, which you can do in your head or on your calculator, and that gives you 5 over 4. Now remember, excuse me, with these questions, you need to half the number in front of x and then square it. So what's 5 over 4 when you square it? Let's just forget that for the moment. 5 over 4 when you square it gives 25 over 16. Now, what does that become if I want to factorize it? I've really sort of left myself not much room there, so let's go to blue. It's going to become x plus half the number in front of x is 5 over 4. There's my answer if I want to leave it in fraction form. Now, part C. First thing we need to recognize is that it doesn't start with an x squared. There has to be a 1 in front of it. So that means I actually have to rewrite this question as 3. 3 goes into itself once. 3 goes into 18 6 times. And I have to figure out what number goes there. So what's half of the number in front of the x? Oops, that's not the one I wanted. Half of the number in front of the x is Half of minus 6 is minus 3. Don't forget that we then need to square it. Minus 3 times minus 3 gives plus 9. Which means I'll end up with 3. Half of the number in front of minus 6 is minus 3. We end up with that. Now that's technically not correct. We'll talk about why later. I'm just going through the process of what number goes to finish to allow you to complete the square. Right, let's get on to 216, which is where we're going to be cancelling fractions that are algebraic. So, step 1, always factorise before you cancel. So, for the first one, I notice on the top of the fraction everything is divisible by 5. So I'm going to take out 5 as a common factor. 5 goes into 24 times. 5 goes into itself once. It's all over that. Now I can look at that and say, hey, those two 5s cancel, and all I'm left with is the bracket a plus 4. We're finished. Now with part B, a little bit trickier because sometimes with these ones you're going to have to work to the side. So what I'm going to be doing now is focusing on the top part and seeing what it generates. Now I know that it's a quadratic. It's not a monic quadratic, it's a non-monic quadratic. I need two numbers at times to give 3 times minus 8. Two numbers at times to give minus 24. That add to give negative 2. So I'm just focusing on this question as though it was a question by itself. They add to give negative 2. So what are two numbers that times to give negative 24 and add to give negative 2? I'm going to go with negative 6 and 4. I'll times to give negative 24 and I'll add to give negative 2. Which means if I'm factorising that, I'm going to get 3m over 3. One bracket gets a minus 6, the other bracket gets a plus 4. And I can see that 3 will divide into the first bracket, which means this is my factorised statement. When I'm looking up here, 3 goes into 3 once and 3 goes into 6 twice, so I get m take 2, 3m plus 4. That is what this quadratic factorises to. Now, it's all over m cubed take 8, which is a difference of perfect cubes. And you may or may not remember your formula, and you can look it up certainly, but difference of perfect cubes is equal to this formula here. A squared to that. Now, remember a stands for the cube root of the first term. Now m times m times m gives m cubed. So wherever I see the letter a, it's going to be replaced with m in the formula. Wherever I see the letter b in the formula, what's the cube root of 8? The cube root of 8 is 2. So where I see a b, it's going to be replaced with a 2. Which means, here's my formula, a take b becomes m take 2. The a number needs to be, the a number, that's m, so it needs to be squared, so I'll get m squared. Formula says a and b need to be multiplied together. That's a, that's b, m times 2 gives 2m. And then the formula says the b part must be squared. 2 when you square it gives 4. When I look at this, I can see that I have two identical brackets that can cancel each other out. which leaves me with my final answer. You don't need to write the brackets if there's just one bracket on the top and one bracket on the bottom. Oh, I am missing something though. I'm missing my squared. Let me go and put that back in. Hopefully you recognize that when I was doing that I accidentally missed that squared from the formula over here. Right, that's the answer to that one there. So when you're factorizing algebraic fractions, you need to take out a common factor or factorize to get into brackets. Once you've done that, then you can cancel.